this presentation, we will discuss what is the difference between latch and flip-flop. So for this purpose, let us consider the circuit which is shown in the figure. From this figure, we find that the circuit shown in orange is a very familiar circuit which we have already discussed in the previous class. This is our SR latch. So we find that there is no control input given to this circuit, and in this case, when there is no control input given to this circuit, then the values of S star and R star can be changed accidentally or intentionally. Therefore, this circuit is not suitable for use. So we need to introduce a control input to this circuit. So for that purpose, we have added two more NAND gates to this circuit. The output of this NAND gate is input to this NAND gate. Similarly, the output of this NAND gate is input to this NAND gate. Now these two NAND gates has two inputs each. One of the input of this NAND gate is S and one of the input of this NAND gate is R. And there is a common input to both of these NAND gates. This is the controlled input. Now we can use this circuit both as a latch as well as a flip-flop. So let us see how we can use this circuit as a latch. The only thing which decides whether the circuit is working as a latch or a flip-flop is this controlled input. If this control input is not a clock but it is just enable EN, then we can use this circuit as a latch. So when enable is high, the latch will operate. When enable is high, it means that this circuit is level triggered. That is, it is sensitive to level triggering. So in order to understand it, we have drawn a enable signal. This is a random enable signal which we have drawn here. So this circuit will be operational when the enable is high. That is, when the enable is high, that is for this period, and for this period, then in that case this circuit will be operational. And when the enable is low, then this circuit will not be operational. That is, when the enable is low for this period, for this period, for this period and for this period, this circuit will not be operational. So whenever this is the case, that is whenever there is enable signal, then this circuit will work as a latch. Now if we write the equation for S star, it will be equal to S complement plus En complement. Similarly, R star can be written as R complement plus En complement. So when enable is high, that means that En complement will be 0. So in that case, S star will be equal to S complement. Similarly, when enable is low, in that case En complement will be equal to 1. So the value of S star will be equal to 1. So we find that when the value of enable is equal to 0, that is enable is low, then the value of S star is coming to be 1 and the value of R star is also coming to equal to 1. Now because enable is given as input to both of these NAND gates, and whenever this is a SR latch will NAND gate, then when the value of S star is 1 and the value of R star is 1, then we will get the output as memory. That is, when the value of S star is 1 and R star is 1, then we will get the memory. So whatever the value or state is stored in this latch is stored until we change the value of En. That's why we call it SR latch with controlled input. So this is the working for this. And this case, when there is enable, we will call this as latch. Now let us see when the circuit will act as a flip-flop. It will act as a flip-flop when we are giving clock in place of this enable. And we know that a clock signal can be represented like this, and the duty cycle for a clock is 50%. So this circuit will be triggered in case of clock only when there is edge triggering, which means that whenever the value of clock goes from low to high or from high to low, that is during this period or this period, then during this period only this circuit will be operational, and in that case we will call this circuit as a flip-flop. So at last I would like to give you the conclusion for the difference between latch and flip-flop. The conclusion is that the latch is level sensitive, whereas the flip-flop is edge sensitive. The latch is level sensitive, that is whenever there is input, then it will check the input, that is whether it is enable. But in case of flip-flop, it will check for the input and the circuit will be operational only when the clock is changing from high to low or from low to high. Now let us come to the definition of latch and flip-flop and see what is the difference between latch and flip-flop. Now both latches and flip-flops are the basic elements of any sequential circuits, and these are used to store information. One flip-flop and latch can store one bit of data. The main difference between the latches and the flip-flops is that a latch checks the input continuously and changes the output whenever there is change in input. But flip-flop is a combination of latch and clock that continuously checks its inputs and changes its output correspondingly only at times determined by the clock signal. And as we have already seen, a latch is level triggered, whereas a flip-flop is edge triggered. So this is the difference between latch and flip-flop. Hope you have got it. That's all in this presentation. See you in the next one.